Boys and girls, I'm going to start another class on the basis of current electricity, and in this class I'm going to discuss a creative question. Now boys and girls, you see there is a board question is given on the board. That is, here there is a circuit. In this circuit there are 4 resistors here, R1, R2, R3, and this one is R4. This one is R4. Will you come to 10 ohm? And all of the resistance is connected with the battery, and this battery voltage is here 6 volt. Now, boys and girls, the question number A. The question number A, that is what is called conductance. And question number B, why electromotive force is always greater than voltage difference. Then question number C, calculate the total circuit current of the circuit. And then question number D, that is, do you think each resistance can carry equal current? Explain mathematically. Now, boys and girls, I'm going to solve this creative question, and I'm going to start my solution from question number A. So, solution of question number A. Boys and girls, this question number A, what is called conductance. You know very well, conductance is the electrical property of any conductor, which can help electricity when electricity passing through any electric device. I repeat, the electrical property of any conductor, which can help when electricity passing through any conductor or any kind of device. Okay, so the electrical property that helps electricity when electricity passing through any device, this property is called conductance. Now, question number B, that is, why electromotive force is always greater than the voltage difference. Before discussing this, I need to draw an electric circuit. It's a very simple electric circuit. This is this is a very simple electric circuit. This is a resistance, external resistance, and then this one is connected with the battery. This one is a battery, and with the some electric wire. Say electromotive force of this circuit is E. This circuit has an internal resistance, and the value of that internal resistance is small r, and the value of this external resistance, that is capital R. This point is point A, and this point is point B, and this is an electric switch. Now, when I turn on this electric switch, then what is happening here, or what is happening here? When I turn on this electric switch, then I can say that this battery or cell, combination of some cell, will produce here I amount of electric current. I repeat, I amount of electric current. And this I amount of electric current passing through the circuit. Okay? And when this I amount of electric current passing through the circuit, then this external resistance can lost, can experience, can consume some part of voltage, that is called V. Voltage dropped by external resistance, and some part is lost inside the battery, that is called lost potential. That is called what? Lost potential. So we can say that this is the total voltage or total electromotive force of the circuit, and this E will be the combination of this capital V and this small v. I repeat, this capital V and this small v. So I can say here electromotive force E will equal to V plus small v. In short, this small v is called lost potential. Lost potential. And then this capital V is called voltage difference. Or is also called voltage drop. Okay? And this E is called electromotive force. Electromotive force. Okay? Now, from this discussion you can say that here electromotive force E from this discussion you can say that here electromotive force E must be greater than voltage difference. I repeat, here electromotive force E must be greater than voltage difference. So here I can say that E must be greater than V. And this is the question, that is why electromotive force is always greater than voltage difference. Because electromotive force is the total voltage in the circuit, and voltage difference or voltage drop is the voltage drop by considering a very small part or by considering a some part of the circuit. So this part will consume voltage V, but the total voltage of the circuit is the electromotive force E. That's why you can say that E is always greater than V. Now, boys and girls, I'm going to discuss question number C. I'm going to discuss here question number C. Okay? At question number C. You see, boys and girls, in this circuit here, calculate total current of this circuit. You have to calculate the total circuit current here. Boys and girls. You see here resistance R1, and after crossing resistance R1 at point A, there are three branches here. One is R2, another is R3, another is R4. And at point A, because of these three branches, electric current will divide into three parts. Say, when you connect the switch, whole circuit or battery will produce here I amount of current. And this I amount of current, when reached at point A, I is divided into three parts, not equal parts, three parts. Okay, so some part of current passing through R2, that is I2, some part of current passing through R3, that is I3, and some part of current passing through R4, that is I4. Since electric current divides into three parts at point A, and those current coincide or combine together at point B, that's why this path is called parallel path, or this connection is called parallel connection. So R2, R3, R4 are connected here in parallel connection. Now I need to calculate equivalent resistance of this circuit connection in between AB part. So the total resistance here RP will equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. So 1 divided by 1 by R1, no, 1 by R2, 1 by R3, and here 1 by R4. Now R2 will equal to 12 plus R3 will equal to also 12 plus R4 will equal to 10. After doing calculation, you'll get a resultant resistance, that is 1/12 plus 1/12 plus 1/10. So resistance will be 3.75 ohm will be the resistance in this parallel connection path, and this three resistance connected in series with R1. So total circuit resistance here R will equal to R1 plus RP. So R1 equal to here 10 ohm plus RP equal to here 3.75 will equal to 13.75 ohm. This is the circuit resistance of this circuit. This is the total resistance, total equivalent resistance of this circuit. So I can say here RP will equal to 3.75 ohm, and here R equal to 13.75 ohm. Now, boys and girls, I'm going to solve my question number D. I'm going to solve my question number D. Okay? So in question number D, you see, question number D, do you think each resistance can carry equal current? Explain mathematically. So I need to find out the branch current as well as each resistance current of the circuit. I repeat, I need to calculate the electric current of each resistance of this circuit. Now, boys and girls, you see here the total resistance or equivalent resistance of the circuit is R equal to 13.75. That you already find out in question number C. So total circuit current I will equal to E divided by R. So E equal to here 6 volt and R equal to here 13.75. Okay, so total circuit current, if I going to find out the total circuit current, that is 6 divided by 13.75, that is 0.44 ampere current, that is 0.44 ampere current passing through this circuit. So total current of this circuit is 0.44 ampere. Then I'm going to find out the circuit current of R1, that is I1, then I2, I3 and I4. I repeat, I'm going to find out the branch current as well as the individual resistance current I1, I2, I3 and I4. You see, when battery will produce I amount of current, this total I amount of current flows through the resistance R1. This total I amount of current flows through the resistance R1. So when total current flows through the resistance R1, that's why I1 will equal to I, and this I will also equal to 0.44 ampere. So this 0.44 ampere current flows through the resistance R1. I repeat, this 0.44 ampere current flows through the resistance R1. And then At point A, this current divides into three parts. One is I2, another is I3, and the last one is I4. So before finding out this branch current, I need to find out the voltage drop in between AB part in the circuit. So the voltage drop in between the AB part of this circuit, in between the AB part of the circuit, that is V will equal to I into the resistance of that part. I repeat, V equal to IR. This must be the Ohm's law. If you find out the voltage drop of a individual part of the circuit, say in this plot I'm going to find out the voltage drop in between the AB part of the circuit, this individual part of the circuit. So when I want to find out the voltage drop at a individual part of the circuit, then I need to use R equal to the equivalent resistance of that part. I repeat, I need to use the resistance that will equal to the equivalent resistance of the branch or of that part. So here R equal to 0.44 and here RP, that is 3.75. So total voltage drop is 0.44 into 3.75, that is 1.65 volt. What? That is 1.65 volt. Since these two resistors are connected in parallel connection, in which part? R2, R3, R4. That's why each resistance can lost or can drop this V amount of voltage. So for the case of resistance R2, voltage drop is V. For the case of resistance R3, the voltage drop is also V. And for the case of voltage drop at R4, that voltage drop is also V. If you consider this concept, then you can say that for R2, V will equal to I2 into R2. Now I2 will equal to V divided by R2. So V equal to here 1.65 and R2 equal to 12 will be 1.65 divided by 12. So the amount of current is 0.1375 ampere. And then for the case of R3, you can say V equal to I3 into R3. So this I3 will equal to V divided by R3. Okay, now this will give you the same result. Divided by 12 will equal to 0.1375 ampere. But for the case of resistance R4, the equation V will equal to I4 into R4. So here I4 will be V divided by R4. So V equal to 1.65 divided by R4, and R4 equal to 10. So the result is 0.165 ampere. From this calculation, boys and girls, you must say that, I repeat, From this calculation, you must say that the electric current at resistance R1 0.44 ampere, at resistance R2 that is 0.1375 ampere, at resistance R3 same as R2, and for R4 that is 0.165 ampere. That's why electric current of each resistance is not same. Now that's the end of my this creative question. Then I'm going to give you a creative question as a homework. So your homework, okay, now this is the circuit that you have to solve at your home, and this is your homework. But you can solve this circuit for these following questions. You see here at question number A, what is called conductance. Question number B, why electromotive force is always greater than the voltage difference. At question number C, calculate the total current of the circuit. At question number D, do you think each resistance can carry equal current? Explain mathematically. So at home you are going to solve this question at your home. So thank you very much. Thanks to all.